Yeah. Okay, so as I told you, I'll be doing this example in front of you so you can see it. And you can redo it by yourself after. And it's really easy. Add components from the library, connect them, do some adjustments through simulation parameters, and after that you can run that simulation and get the results. So that's those steps. They are just showing you step by step how to model this this circuit here. Okay. So now that's same thing for the next page. Okay, they're continuing here, explaining the other steps, the rest of the steps. Okay, and display your results. Okay, through oscilloscope like this. So this those two pages will be explained right now through example. I'll share with you my application, MATLAB application. So I'll share the screen with you. Share application screen. Okay. I'll open MATLAB. Yeah, keep in mind here, MATLAB has one small issue, which is if you do your circuit or your M file, M file means MATLAB file, and XLS file, that's a Simulink file. So if you do any one of them with the newest version, for example, 2019, I cannot open it with 16, the one I have. I have 18 also. But you can do, once you need to save your file, you have to select and save with the previous versions, for example. And you can do it, for example, if you have version 2010 or the other ones, you can do it and save it and send it to me. Okay, so now I launched MATLAB. Yes, Mohammed? I launched MATLAB, so that's the first step to do if you need to work with the Simulink. You have to open MATLAB first, and from MATLAB you can launch Simulink, another window separate from that one. But they are connected. If you open MATLAB and after that you open Simulink and you close MATLAB, you're going to close everything. So MATLAB should be open all the time behind the scene. Okay, just wait a little bit. It's a big software. Because as I told you, it has Simulink embedded, and Simulink has, my Simulink here has a lot of toolboxes. It takes time to launch all of them and prepare them for us. Do you have any questions before this one started or starts? Guys, can you see my screen?
Yes.
Okay. Okay, so I have MATLAB launched here. Okay. Just 1 second. It's a white screen. Yeah, I have it here. Do you see that one, right? Do you see my MATLAB screen? Okay, now I'm going to explain that exercise, the small exercise. And if you don't stop, it means you are hearing me well, you're following me, and everything is okay with you. Okay, now to launch MATLAB, Simulink, we have two ways. We have this icon here, Simulink icon. You can click on it. This will launch, will start Simulink, or you can type it in the command window here. Okay, it's sensitive here in terms of capital or small letters. So all small letters, Simulink. Yeah. You click enter will launch Simulink. Or as I told you, you can click on this button here. This will start Simulink. Okay, it's starting. Okay. So by default, this one comes, this window pop-ups here, and there you have different icons, and the title of each icon explains exactly what is that icon. So for our case, we'll start with the blank model. Okay, so click on this icon here. This will start a blank window. Okay. It's a big software, and that's why it takes time to launch. And you know, big companies outside everywhere in the world, and most of them, I can tell maybe more than 90%, they are using MATLAB for their simulation. Big engineers, they're using that this Simulink here. That's why it's expensive. And also, once you need to buy this, they have student version and they have business version. Business version, it's a big one. They have a lot of models, a lot of toolboxes. You know, aeroplane, they are using this Simulink to simulate their planes, and you know, cars like Ford, like big companies, they are using this Simulink to simulate their products. So in research also, in my research, I'm using MATLAB Simulink to simulate my researches. So here we have this window. It comes blank like this. Just maximize this a little bit. So if you remember in our small exercise, we have to take a block for a sine wave block, generator of sine wave, and we have to integrate that sine wave to get cosine, and display those two signs or those two signals, sine wave and cosine wave. So to do this, look, if you raise your hand, I cannot see it right now, but you can talk if you have any question. Yeah, yes? Okay. So first of all, once this Simulink window starts like this, we have to, it comes like with the title, and it's untitled, means there's no title for that one. I'll keep it for the time being like this because I need to show you something with this one before I change its name. After that, we start the library. This icon for the library here, this blue and red and white small squares, those for the library. We have different toolboxes. Okay, my version is, you know, let's say between parentheses and a professional one. That's why I have a lot of toolboxes here, and that's why it takes time to launch because it has to launch one by one, initialize them, sorry, and get them ready for us to be used. Okay, so that's the standard one, Simulink library or toolbox, and you have different ones here for different applications. Now, that's the step where you have to open your library. Now, what do we need? We need the sine wave. We have two ways. Search that sine wave here in Simulink toolbox, or you can type it here. Sine wave. Space and sine wave. Okay. So we have that sine wave, different type of sine waves. I'll take this one generator that generates. Okay. This one, if you need to have a block where you have to type your equation for sine wave, Vmax sine omega t plus, you can build your own sine wave. Here, it's already ready, so you can take this one. How to take this one here? We have different ways. We can drag and drop like this. It will come. Or yeah, it's here. Or what you can do, you can right click on the block you need to add to your window, and there, look, add the block to model and untitled. You see untitled means this one. So now if you go back here and save, it's super slow, this one. Save this one in, for example, let's say desktop, lab machines. I'll call it lab 1, for example. And keep in mind, please look, okay, some versions, maybe all of the versions of MATLAB, you don't accept space once you name your file. So here, dash or underscore, name this file. I call it lab1 underscore 2 because 1.1 was yesterday, exercise, and 2 for you, and they keep lab1 for your real experiment or simulation to be done for this experience, for this lab session. Guys, I hear a bit from you. If you have any, and I don't see the hand if it's raised. As I told you, if you have any question, you can stop me, interrupt me, and ask your question. Okay, so I'll call it lab 1, 2. I'll save it. Okay, it will change from untitled to lab 1, 2. And here right now, if I come here, right click and look, add block to model lab 1, 2. Because sometimes I can have more than one window, more than one project open here. And once you right click on that one, this window will ask you to which window, which project you need me to add this block. So I'll add it to this one here. You see, right click, you select that file, and the block will be added to it. To delete, you have just to click on that block and click delete from your keyboard. So I need this one. I need integrator. I think integrator is in continuous block here, or you can type integrator. Okay, so I have one integrator here from the same window, same toolbox. So that's the integrator. I need to display that one. I can use scope, or I can search for scope from sync here. Okay, so I can enter, or I can search it from sync here. So that's scope. Let's click add to this model. Here I have two things. I can connect display that sine wave directly in my on my oscilloscope, and this one also in the same oscilloscope, or I can collect both of them and display them in one axis. How I can do that? If I need to collect them, and I need, I'll do both of the situations. Here I come back here and look for I think routing, yeah, or I can type max, MUX. So max will collect more than one signal and collect them, and like a bus will send them here to oscilloscope. So I'll take this one. Here I can have by default comes like 2 inputs. If you double click on it, you can make 10 inputs if you like. Okay, you can maximize this. Okay, so those are 10 inputs. You can collect 10 signals, for example. I'll bring back this one to 2. Okay, Control Z, Control Z, Control Z. Okay, now to collect those signals, look, the new versions. Okay, they show like a blue line. If I release my mouse, it will be here, and I'll just click on it. This is a connect, or you can click here with this plus, pointer, and drag and drop here. This is how you can connect or wire your circuit. This one I'll ask to bring that sine wave to this integrator. One more thing, I can also click on that icon. Okay, it's selected, and press on Control key from your keyboard and click on the next where I need to connect that block. Okay, it will connect this one directly like that. Same thing. Look, I will select this max block and hold on control key, press on that one. It will connect this directly. So this is one option. Another option, if I need to copy and paste, we have select that one, control C and control V, or the easiest way, which is right click on the one you need to copy, right click, not left click, right click and drag. This is copy and paste like this quickly. Okay, so now I need to take those two signals and put them here. So that one has by default one input. Double click on the scope. Okay, a pop-up window will appear for that scope. Okay, so here through this icon for settings for that, or parameters, or configuration properties for that oscilloscope, just click on it. Another window will appear here. Number of input ports, and make them 2, because I have 2 signals. Now, if I click apply and OK, both signals will be accepted by this oscilloscope, but they will be displayed on the same axis. But for my case, I don't need them to be on the same axis for that case. I need them to be separate in each axis. So now what to do? Once I select 2 here, I go to layout, click on it. The matrix will appear, and here you can either put them horizontally or vertically like this. So by doing this, I'm asking MATLAB, this Simulink, or this oscilloscope, to display the first signal in one window and the second one in the second window like this. So now 2 signals in separate windows. The main window, but inside separate axis, like this one here, like this. Okay, now I close this. I don't need it. It's ready now to accept 2 signals and display them separately. So I'll connect and display sine wave and display cosine. Okay. By default, we have 10 seconds here for a time simulation, but we don't need them. These 10 seconds, I'll keep it now just to show you what will happen. But after that, we need less than that. And I'll show you how to calculate the time simulation if you like. Okay, I launch this. We'll get some signals. Those signals, they will not be perfectly sine waves. I need to show you that those are not non-perfect sine waves. And after that, show you how we can smooth them to make them more sine waves or a cosine wave. To launch this, we click on this run here, this button. So in run, first of all, this Simulink will compile this one. If it's okay, it will start simulating this. Yeah, I think it was simulated. Now, if I click on this oscilloscope, double click on it, this will show me. So just click on this because yeah, there is one thing I didn't change. I'll close this. Those are the parameters for each block, but especially we have right now this block here to be adjusted. Double click on sine wave. It comes 1 volt, 1 hertz. That's why it takes like long time to appear. 10 seconds for 50 hertz. It will show like hundreds, maybe thousands of cycles, not one cycle or half of the cycle as it was with this one reading per second. Okay, so now by default it comes time based. We keep it like this, simple base. This is if you connect your microcontroller, because your model can be uploaded in microcontroller, physical one. For us, it's only simulation. We keep it time based. Here we use a simulation for the time simulation for the Simulink itself. And if we need the external one, we can use external signal where we can use this time simulation. Okay, we keep these two here, these two parameters as default parameters. Amplitude, I'll make it 120 volts, for example, as a peak value. Bias, we don't need to bias this one. Offset means offset in above zero axis, x-axis, or below zero x-axis. Minus bring that signal down, plus will bring it up. We keep it zero means we swing around x-axis. Positive sequence and negative sequence equally. The frequency here, look, you have exactly to follow what they are asking for. The unit here. The frequency usually it's in hertz. Okay, for our case it's 50 hertz, but we'll change it to radian per second. Okay, change it to radian per second. We'll type the equation here: 2 times pi times 50 hertz. So by doing this, we are converting from hertz to radian per second. Phase shifts, we'll keep this one as reference. There is no phase shift. My signal will start from 0. And sample time will keep it 0 because we are not working. We are not working with the microcontrollers, so we keep it 0 like that as the default value. So everything will be kept like default values, and the only things to be changed for our case, amplitude and frequency here. Click on OK. Now here doesn't require anything. The integrator, which is 1/s. Let's start now. Now it's going to take a little bit of time. It's quick. Double click on this. Look, you see how many cycles do we have? Okay. You have lots of cycles. What you can do here, we can zoom in by selecting that horizontal, zoom. Okay, it gives us something like this. And as I told you, this is sine wave for now. We need to smooth this one to make it more realistic. The other signal is small, so vertically here we can zoom on that signal. Okay, and you can see it's a cosine. Cosine because once this one here crosses 0, the other one is either minus 90 or 90 degree. So that's sine and cosine sine wave. Okay, I'll close this. Adjust now parameters just to make it smooth. This is one, and I'll show you how you can calculate the time instead of showing a lot of sequences and select by or zoom in to select number of sequences and wanted or needed. I'll show you that. So through simulation menu, we'll open this model configuration parameters. Okay. It's coming. Okay. So here we have different categories here, but the default one is solver. We keep it solver because if you change this optimization and the other types of options here, the window will change. Keep it default solver. Just add here open more options, and instead of auto, we'll make it a little bit tight. We'll fix those minimum and maximum step size. Okay, usually that tolerance here will be 1 times 10 to the power of -3. These ones usually they are smaller than this tolerance. So it will be 1e, which is exponential to the power of -4 as a maximum step, and 1e minus 5. Many years I was working with this and those numbers 4 and 5, and sometimes 5 and 6. They are the perfect ones to smooth all signals inside your simulation. So we'll keep them now 1 to the 10 to the power of -5 and 10 to the power of -4 as minimum and maximum steps. We'll keep everything as it is, and we'll click just on apply and OK. Now, before I start this, let's calculate that one, this one here. To do this, I'll open a new blank window and come back to my application. So go back to Blackboard here. Where is it? Share window. So a sine wave like this has one sequence. Once you write in a Vmax, okay, sine omega t plus theta or phi. This is the general expression for your voltage, or for example for V, or your voltage in time. Okay, so Vmax, that's the Vmax, and for each time we will be having a value for sine wave here and so on, negative and positive sequence. If there is no phase shift for our case, so this one will be 0 degree, and your sine wave will be Vmax sine omega t, 2 pi ft. Okay, so this omega will be all the time fixed, 2 pi 50 hertz. I'll adjust my pen after it's thick one. I don't know how to adjust it here. And the time, this is based on the time. So each time will be replaced here, and the value will be calculated. It's a number. That number will be each point here, and you can build your sine wave like that. Okay, that sine wave, it starts from 0, goes through 0 again as a positive sequence, come back as negative sequence here, and goes back to 0. From here, this will repeat itself, and this repetition here, or the time when this one starts to repeat itself, we call this one sequence. And the sequence is represented by a period time t. This t is 1 over f, the frequency, all the time. Okay, so now for our frequency is what? Is 50 hertz. Sorry if the the numbers or the letters, they are not complete by this pen, but this is a 50 hertz. So the period will be 1 over f, and this will give me 0.02 seconds. Okay, as time from here to here. We need 0.02 seconds to display 1 second. If I need 10 sequences or 10 cycles, so those 10 cycles means times 0.02 seconds. We need 0.2 seconds to display 10 seconds. So now in time simulation, we don't need 10 seconds, because 10 seconds, 10 times 10, those are like 100 cycles. Yeah, exactly 100 cycles to be displayed in that screen. But we don't need 100 cycles, we need only 10 cycles. So 0.2, it's enough, maybe less sometimes. We need 0.1 to display five cycles, and it will be more clear on the window. So instead of 10 seconds, we'll replace that one with 0.2 seconds as time simulation time. So now I go back. I hope it's clear, this one. Go back to my application. And open that. Let's open this also behind, just to cover. Sorry, oh no, I don't need to do this. Okay, to cover this. So now this time will be 0.2. And I'll start now with my simulation. It will compile. It will start simulating. It's done. Now, if I double click on this, it will show me time. Look here, this is update. This is auto set. This icon here. If I click on it, it will auto set. It will adjust my signals through that window. So here I have Let's maximize a little bit this window, resize it. So we have, this is one cycle, second one, 3, 4, 5, 6, 7, 8, 9, 10, because we asked 0.2 seconds as a time simulation. So we have 10 cycles. This can be done for any frequency. If you have 1 kilohertz signal, you have to take in consideration that one. So 1 over 1 kilohertz will give me the time for one cycle to be displayed in that window. And now it depends on how many cycles you need to display. You time that time by number of sequences, and you replace that one in time simulation, and you get that number of sequences. Okay, so now we have two sine waves, two signals, the sine wave here and cosine here. Cosine is a little bit smaller because of the model itself. Okay, so we can zoom on that signal, and you see it's okay, it's cosine. This is like offset for that one, but now we don't care about it. We're not solving a problem for sine and cosine. It's just to show you how we can add models, connect them, simulate them, and you know, change things in this oscilloscope. Now this is auto set. Okay, auto set will bring my signal as default display. Before I'll open the other one, we will have two. Let's open the other one. It's better. I'll open this. We'll have two signals separate, displayed separately. Okay, and now the next explanation we have here, sine and cosine. The next explanation, please. I need you to take care about this in your lab reports. The lab reports, I don't need to accept, or I will not accept. I don't need to see your graphs like this from MATLAB with the black background. Okay. By doing this, I need to teach you how you can reach a stage where you have to write your this SDP report or conference papers. They don't accept this one because they need to print like 1 million of copies for your conference papers and to be displayed around the world. So I mean, make prints with that, like maybe 10 or 20 prints will end the ink. So make all the time, and also in as a presentation in the conference paper. Once you present it in a white background, it's more clear for you know, to be interpreted by others. How to change the background? We go to this view menu, and there we have the style. So in style window, the one will appear right now, we have two backgrounds. We have axis background, a color. This is for this background here, and the other background here, and figure for the background outside. So I start with this one, so you can understand what I mean by figure background, the one outside. If I switch this one from black to white, okay, and click apply. Okay, so the background for this will be white, and the figure itself will be black. So let's make it also white to be more, you know, the presentation will be more clear for that one. Now for the signals, by default, the active one is the first one. Okay, you can swap it to 2 if you like. So let's take the first one. I can make it a little bit thick. So 2, for example, and change its color to red color. I can change not continuous line. I can make it dashed lines like this, or I can keep it like that. You can add, like for each point, you can add what they call markers. I'll keep these ones by default like that. Apply. So the signal will be red, thick, more clear. I can now select the other signal, number 2. I'll make it like dash lines. Make it 3, for example, but usually we keep to be consistent, we keep the same thicknesses for for all signals, and sorry, and make it blue, for example, and click apply. Okay, so with the points or dash lines and that thickness and blue color. Okay, so this is how you can. I need all your reports to be like this. The colors, this is up to you, but the background, it's up to me. Sorry for that. The background should be white. Now you can print screen this one and paste it in Word. It comes exactly like this. You can also click on File and Print to Figure. So this will open like a file. Okay, so this is Print to Figure, and one more time File and Save As, and you can save your figures in your created created folder. You can name it, for example, figure 1. Figure 1 doesn't matter now in space. Figure 1 for lab 1, for example. Okay. So it's there. Anytime you can, even if we close Simulink and MATLAB, we have the result saved. No need to resimulate again that part. It's saved in our files, in our folders. Okay, I think I covered everything from that lab manual. Okay, if you have any question now in here and in anything you need to know, you can ask, please. Otherwise, I'll go and start talking about the task you have to do for your lab report. Somebody asked? No? No one? Sorry? Yeah. Okay, 1 second. Let's go back because I forgot to tell you one thing. Once I saw this comment here, I go back to my application. Yeah, just 1 second, please. Where here? Yeah. So now there's one thing. I call it myself like driver. That driver should be all the time here, and this driver is called from. You can take it from the library, and it's called Power GUI. So Power Graphical User Interface, Power GUI. But here, all the time present in your file. This is small model, so it took that one. Okay, it passes. But sometimes, especially once we use like integrators, more models, we need this one to be you add it and forget it. Don't touch it. Okay, for our examples. Now, for your question, I think Abdulaziz, sorry. You go back to model configuration. Yeah, here. Just sure that this max is bigger than mean. -5 and -5 is smaller than -4. Just be sure don't write here 5 and 4 here. Should be 4 and 5, and should be take in consideration spaces. Okay, there's no space, and it should be working. Try it, please, and let me know. So this is it's done from my side for this example. So now let's start talking about the experiment itself. I use this blank one. Okay. Now I'll stop recording the first part